All right, so today what we're going to do is we're going to continue our look at finding the gradient. And again, remember I said that the method you use is going to be determined by the information that you have, right? There are 3 methods for finding the gradient. And yesterday we looked at the first one. We used the counting method.
You just count.
Yeah, but you know you use it when you have the graph, right? We have an actual picture of the information. And that we just counted as rise over what? Run. Okay? Today we're going to look at the second method, and that is when you have the equation of the line.
Wait, Mr. Sal?
Uh-huh.
What was the beginning called? Because I didn't get to write it.
Gradient continued.
Oh.
Yeah, no worries. All right, so when you have the equation of a line, who can remember how do I know that something is an equation?
It has an equal sign.
It has an equal symbol. Excellent. Okay, perfect. So you have an equation because of the equal symbol. And now when we have an equation, they can come in all different forms. But when we're working with this particular method, what we want to do is we're using what's called the slope-intercept form of an equation. So again, we know it's an equation because it has an equal symbol. Remember, when you're graphing anything, you have to have something that corresponds to the horizontal axis. Which one's the horizontal axis? The x-axis. And you have to have something that corresponds to the other axis, which is called the y-axis. So you know that it's going to have an x and a y in it.
What is the
slope/intercept form? That's what I'm going to show you. Okay? We haven't gotten there yet, but I'll show you in a second. So this is a specific form of an equation that always needs to be in the same way. If it's not in this form, then you can't read the information out of it that you need. Okay? Think about it like this. Okay? Think about a form. You have a form that has all your pertinent information on it, right? So you could go into the doctor's office and they could give you a blank piece of paper and say, write out all the stuff we need. How are you going to know what they need? Or you go in the doctor's office and they can give you a form that has all the blanks and questions on it, and you put them in the right spot, right? Do you put your last name where you should put your age, and your age where you put your mother's name? No. You put the right thing in the right spot, and then when they look at it, they can automatically find what they need. Yeah? And that's what a form does. Does that make sense? So, if it's where you expect it to be, it's easy to find, right? If it's not, then it's not so easy to find. And so that's why it's important to make sure, guys, that you put it in the right format. And here's the form. The form is y equals m. Have we seen m before?
Yes.
What is it?
It's the symbol for gradient.
The symbol for gradient. So m is the gradient. X plus c.
What's C?
Okay. Yeah, well, just depends on where you've learned it.
What is C?
But in the New Zealand books, they call it C. But it's okay. It makes sense that they call it C, and let me show you why. Okay? Y is your Y value. You understand that? Yeah. So it's a Y. M is the what? Gradient. X is your X value, the X value, right? And plus C means a constant. So let's just dissect it, okay? So we have Y equals mx plus b, plus c, I'm sorry. It's mx plus b everywhere else in the world, but New Zealand for some reason. Okay, but it makes sense, okay? So Y, well, it's the same thing. I just rewrote it. So it's right there. Yeah? I didn't write anything new. Well, don't worry about understanding it yet. I haven't told you anything about it. Okay? So Y is your Y value. X is your X value. So those would be coming from a point if you had a point, right? Like if you had the point 2, 4, 2 would be your X, 4 would be your what? Y, because it's always X comma Y. M is your gradient. And C is just some constant. Now, I've used this word with you before. Remember, constant is just another way of saying a number. And we call them constants because their value never changes, right? Does 4 ever equal any other number but 4? No. So that's why they're called constants, and that's why this is C. It's always just some number at the end.
Then why is it what's B?
It's just another way of writing the same thing.
But like, if you were in America and you were teaching this exact same
I would
thing,
write y equals mx plus b, and I would just say b is some constant, which makes more sense to say c. So this is the one time I agree with New Zealanders. Now, I agree a lot because I live here.
Z.
No. Okay, y, the y value, x is the x value, m is the what?
Gradient.
And c is the what?
Constant.
Constant.
Or
Okay?
number.
All right, and constant just means a number, right?
It's not all that.
Okay? Now, one of those things is the gradient. The m. And m is always, guys, m is always in the same place. Where is it? In front of the x. So it's the coefficient of x. Right?
Hold on.
Therefore, the coefficient just means the number in front of the x. Whatever number you have in front of your x is the gradient. So all you have to do is read it. Okay? But it must be in this form. Okay? So let's talk about the steps for using it to find the gradient. To use the slope-intercept form to find gradient or change or slope, right? First, solve the equation. Write it down, then I'll show you what it means. Don't panic first. Solve the equation for y. Now, solve the equation for y means that the y has to be completely by itself. Do you remember when we talked about equations? That's how you know that the equation is solved. The y is completely by itself on one side, right? Well, if you go back to the format for this, it says y equals. So in other words, y is completely by itself on one side, and everything else is on the other side. Sometimes, or most of the time, they may give it to you that way. But if they don't, then you're going to have to add, subtract, multiply, whatever you divide, whatever you need to do to get the y completely by itself on one side. Okay? All right? So again, looking at the format, do you notice that the y is completely by itself and every other part of the equation is on the other side? Okay? It has to be that way. Okay, good. If it's not, then you have to solve it. You have to do some work to do it. And we'll look at them both ways. Second,
Babe, it's Dad.
simply find m. And you're done.
Are you
Whatever
okay?
m is your gradient.
How do you find M?
It's just the letter where?
With a
Gradient. M.
Where is it in the equation? In front of what?
What?
Where is it in the equation? It's in front of x.
X.
It's in front of x. So whatever number's in front of x is your gradient, period.
So how do you know it isn't on the graph?
All you need to know is, no, we're not having a graph. We have an equation. We'll look at some examples. Shh, guys, come on. We'll look at examples. Don't worry. All right, so solve the equation for y unless it's already done for you. And then you simply find your m, and whatever m is, that's your gradient. Don't make it harder than it is.
What happened with X?
No, we don't care. All we're looking for is the gradient.
Do you use the X to help find the Y?
Let's look at some examples. Okay. All right.
Are those the only steps?
So here we go. Yep, that's it. So say, for example, I have y equals 3x plus 5. First of all, is it solved for y?
No.
Oh, yes.
It's not because the Y is.
Is the y on one side of the equal symbol all by
It's
itself?
on the other side.
It's like I'm talking. Okay.
What?
Yeah.
How do you know?
Well, is the y completely by itself?
Yes.
Is the y completely by itself on one side of the equal symbol?
Yes.
That's the definition of solving an equation, is to get the letter completely by itself on one side of the equal symbol.
Can you quickly write what it would look like if it was solve?
No, we'll do some in a minute. Yeah, but for the moment, let's just worry about what we got. That's not new. Okay. Then, your gradient or slope is simply the number that's where? In front of the x, which in this case is what number?
3.
So your gradient is 3. Okay.
Is it?
Yeah.
Oh, that was so easy.
Y'all are making my life so hard. It's so easy. Just read it in front of the x, okay? But the problem is that if it's not solved for y, you're going to want to just read the number in front of the x, and you can't do that, okay? So that's why I'm making a big point of it. All right, so here we go. Y equals negative 3/4 x minus 2. Is the y by itself?
Yeah.
Then it's in the right format. What number's in front of x?
Negative.
So that's your gradient.
Ah.
Okay.
Okay.
What do you do with the x minus 2?
You don't care. All we're asked to do here is find the
So
gradient.
it's irrelevant.
That's right, for what we're doing right now.
Kind of is.
Y equals negative 5x plus 6. Is it solved for y?
Yes.
Yes. So what's my gradient?
Minus 5.
Done.
Thanks.
It's just a matter of reading it. It's a form, right? Do you need to rewrite the form to find your age on the form? No. You just look for the right place, look for the right spot that says age and read it. That's all you have to do here. It's a form, just like that kind of form. All you're doing is reading the information straight from it. Y equals negative 6,315 x plus, plus 1/2. Who cares? Is it solved for y? Yes. Then where's my slope? In front of the x? So what number is it? What is this gradient?
Minus 6,315.
There's your slope. Doesn't matter. It can be a fraction. It can be a decimal. It can be a whole number. It can be a very small number. It can be a little tiny number, a big number. Yes.
What happens if you don't give them the
It's always there.
Oh,
Okay? Watch. Watch this.
If you do
Y equals x plus 3.
1.
It's 1. Yeah. There's no no.
Because if the number's not given, then what do you assume it to be?
1.
Wait, in
A one.
IB math, do we have to calculate the...
Okay.
And if you did IB math, would they not give you the end?
I don't know.
You
Okay.
don't teach IB math?
No. Here we go.
Oh.
Now, look at this one.
Oh no. Oh.
Y plus 2x equals 4. Is the y by itself?
No.
So my slope is not 2. I can't read it until that y is completely by itself. What's over there with that y that I need to move?
2x.
Positive 2x. How do I move a positive 2x? We'll subtract 2x from where? From both sides, yeah? Over here, there's something going to subtract away, which leaves me my y. Now over here is 4 minus 2x. Are those like terms? No. So therefore they can't be combined, right? So I'm going to get negative 2x plus 4. Go ahead and write it down, and then we'll start the screaming, and then I'll tell you why. Okay? We need it to be in the form y equals mx plus c. So I want the number to come after the x term, and that's why I put them in that particular order. The x term comes first, and then the number.
But it was always first anyway.
Well,
But
when you moved it across, you could write it like that, but we don't want it like that. We want them swapped. We want the number at the end.
I've
And
never ever written it like that. I don't understand.
Well, there you go.
What?
Perfect. Don't worry about it.
Is that why I failed my algebra system?
No. Okay? Yeah. Yes, was there another question over there? Normally, the order of the x and number wouldn't make any difference, but here we're specifically putting it in this format. And you're going to see why later, too, that this format is so important.
But you minus.
So always put it. Right.
Wait, how come we have minus 2x?
Because what sign was it originally?
Positive.
And we have to get rid of it. So we do the opposite. What's the opposite of plus 2x? Minus 2x. Yeah, we're just solving the equation. Okay? All right, so look at another one. 3y, we're going to do, equals 6x plus 15.
The first thing you do is divide
Yeah, you bet. So what we have here is my y completely by itself. No. How is the 3? Oh, sorry. How is the 3 attached to it? Multiplication, and the opposite of multiply is divide. But remember, we have to divide it equally, right? So that means all the way across. And so normally what I would do is I would just write both sides divide by 3. Over here, these 3's are going to divide away, which leaves you just plain old y. And on this side, but I can't have this fraction. This looks weird. I can't read it effectively. So I need to get rid of it. So what we're going to do is, instead of writing one big fraction, that's the same as saying both of them divided by 3 anyway. Okay?
What's the difference?
Because now, 6 divided by 3 is what? 2x. Positive 15 divided by 3 is what?
5.
Positive 5. You've got to have a plus or minus, though, guys. Be careful about that. Now is the y by itself?
Yes.
So what's my slope?
2. Wait.
Just 2. Just 2. It's just the number in front, not the x. Okay?
So that makes
So you're just solving the equation. So just do the opposite to get the letter completely by itself. Okay? All right. Let's look at another one.
n equals
Hello, sir. Pretty good, thanks. What's up? Okay. So we added our 4x to get it from both sides. So that gives us our 2y. Over here, that gives us 4x plus 16. And again, to get it in the proper form, we always put the x term first, right? But is my y completely by itself yet?
No.
Nope. It's attached to that 2 with what operation? Multiplication. So what we'll do is what? Divide. We'll divide every single term by what? 2.
this stuff. I feel like we're back in algebra and I don't know.
Because the opposite of subtract 4x is add 4x, so we had to add 4x. So do the opposite.
Wouldn't that make 0?
No. It did on this side, but it didn't on this side.
Why didn't you just
Hey?
add plus 4 each?
Anyway. Let me finish and then we'll come back. Now, over here the 2's will divide away, give me y. 4 divided by 2 is what? 2x. And 16 divided by 2 is plus 8.
Wait.
Now is the y by itself? Yes. So my slope is what? I'm kind of fond of 2's apparently.
This is not fun.
So the important takeaway here is that it must be in the right format. In other words, solve for what letter?
Why?
Y. Okay?
Self.
Almost finished, if you'll let me get finished. Okay, so here we go. Come on. All right. So let's look and see what the exercises have for us to work on. Okay. So in the exercises, they're going to add the second part of this, so I need to do that as well. Okay? So the slope-intercept form can tell you more than just the slope, because what's it called? The slope what? Intercept form. So the other piece of information that you can get from this form is something called the y-intercept. The y-intercept is simply the point where the line crosses the y-axis. And y being which one? Vertical?
Yeah.
Vertical, not horizontal, right? Okay?
Horizontal.
All right. So, and it's always exactly the same point. you can read it directly from the point slope form. It's always the point 0, comma, C. And where have you seen C before?
C is the constant number.
The constant, right? When it's in the right format.
Wait, what's OC?
Remember, every point always has how many coordinates?
2.
You must have an x value and a what?
Y value.
But at the y-intercept, if I'm on the y-intercept, can I go right any and stay on the y-intercept? Can you go left any and stay on the y-intercept? And that's why the x value is always what number? 0. That's a 0, guys. All right, now, but your y value, it can go up and down and still be on the y-axis, yes?
Yeah.
So your y value can be anything, but the x value has to be 0.
Am I meant to write down 0C?
You meant to write down anything I write down.
Wait, what does 0C mean?
He's like, yeah.
Okay, so 0 means that on the...
So, for example, right? Let's say that's 1, 2, 3, 4. And we have a line doing this. Here is where it crosses the y-axis. Do you agree? Caitlin, you're not looking. I'm doing this for you.
Yes.
Do you agree? Well, what is the coordinate of that point?
0 is 2.
Wait, for the coordinates, is it Y first or X first?
X is always first. So x, we didn't go any right or we didn't go any left. So that means our x value is 0. But we did go up 2. So that means our y value is positive 2. Okay? All right.
Yes, I see. Okay. Wait, hold on.
But because we know that c is simply the constant value from the from the slope-intercept form, we can just read it straight from the graph. And many times, all they want is that y value. So pay attention to what they're asking for. If they ask you for simply the intercept, many times they simply want what c is. If they want the coordinate for the y-intercept, guys, you're not listening. If they want the coordinate for the y-intercept, then they want 0, comma, c. Do you see the difference? So if I just say, what is the number for the y-intercept? That's just plain old what? C. But if I say, what is the coordinate for the y-intercept? That's what? 0, comma, c, and close in a bracket. Do you see the difference? Okay? All right. So, y equals negative 3x plus 2. What is the y-intercept? Positive 2. And make sure you include the sign. What would the coordinate be? 0, 2. Okay?
Wait, how did you get what?
I just made up an equation. And I made up an equation specifically to match the point. No, we're not worried about putting it on the graph.
Plus is what?
Whatever the constant
So
is.
if it says minus 2.
Right? So what if it was y equals 5x minus 5?
It would be minus 5 down the bottom.
There you go. So it would be 0 minus 5.
And then the point would be in the bottom
Okay.
5.
And it would be down there somewhere. Yeah. 1, 2, 3, 4, 5. Okay? All right. Okay? So we're going to look at a few exercises. And the first thing they want us to do is they just want us to find the y-intercept. Well, all we have to do is make sure that it's solved for y, and then it's going to be the c term. Okay? All right? Then I'll show you algebraically why this is true in a moment. All right. Here we go. Okay? So, guys, come on. So here we go. We have our linear relationship. And in this one, it doesn't cross the y-axis, but it still touches it, right? Therefore, it has a y-intercept. So even if it doesn't cross it, it still touches it there.
Y-intercept is 0, 1.
So, yes, it's the point 0, 1, exactly. Okay? Right? So it's that point.